Okay. So yesterday we had winded up the second chapter, second module in your syllabus. Today you'll be starting the third module, which is about memory interfacing and interfacing of microprocessor with peripheral chips. Okay. So you'll be learning several peripheral chips like 8255, 8257, 8259 in this module. So you'll be learning how to interface uh, memory with 8086 and also how to interface peripheral chips with 8086. Okay. Now the question is, what do you mean by interfacing? Does anybody know what is meant by interfacing? What is interfacing? Any idea? I'm audible, right? Am I audible properly?
Yes, ma'am.
Okay. See, we know that 8086 is a very powerful MIPI, right? At that time, when it came into existence, it was very powerful. But 8086, it is powerful, but if you want to exploit its all capabilities, you need to interface it with lot of other peripheral devices. See, inside your computer, you have a microprocessor. The microprocessor is not sufficient alone, right? To get all the functionalities which a computer can provide, you need to interface that microprocessor with several other peripheral chips and memory. That is when you will be able to exploit the power of the microprocessor, right? So what do you mean by interfacing? Interfacing means just connecting your microprocessor with other peripheral chips and memory so that you can use its full capabilities. So interfacing just means connecting your microprocessor with other peripheral chips and memory. Is that clear? The meaning of interfacing? Yes. Okay. So you can interface memory with 8086 microprocessor. You can interface lot of peripheral chips also with 8086 microprocessor. So in this third module, we'll be learning about how to interface memory with 8086 and how to interface different peripheral chips like 8255, 8257, 8259, etc. with 8086. Okay. So first we'll focus on memory interfacing. So today we'll be learning this concept of what is meant by memory interfacing. What do you mean by RAM and ROM decoding? What is partial and absolute decoding? Okay, so today we'll be focusing on memory interfacing as such. Okay, so interfacing does not simply mean connecting peripheral chips or memory with 8086. See, when you're connecting, there are a lot of other things which are involved. You know that 8086 has only a 20-bit address bus, right? And you have lots of, you can interface lots of peripheral chips with 8086. So right now, if you want to say with your computer, you have keyboard connected, you have mouse connected, and you have lot of other peripheral chips also connected. Right now, if you want to send some data from the keyboard to your processor, it is the keyboard which has to be active, right? So even though there are a lot of peripheral chips connected with your computer or your microprocessor, at a time you may want a particular device to be communicating with the MUPI, right? You may want the keyboard to do read write operation, or you may want the MUPI to communicate with the display unit or with the printer or the scanner. So 8086 has a 20-bit address only. So address selection is something which is very important. Even though you have multiple peripheral devices connected with with a microprocessor, when MUPI wants to communicate with a particular peripheral device, that device should be active. That device should get selected, right? And the rest of the devices should be in inactive mode, right? Even though they are connected with the MUPI, they will not be right now communicating with the MUPI. Only the device which is currently communicating with the microprocessor will be selected. That means address selection is something a very important aspect of interfacing. So when you are learning interfacing, we'll be learning how to interface a particular peripheral chip or memory with 8086. So that involves how the addresses are selected. Okay, how the addresses are selected and how the entire circuitry is designed. So first we'll begin with memory interfacing. Okay, let me know if there is any connectivity issue or lag if you're facing. So we'll begin with memory interfacing. After we complete memory interfacing, we'll be going to interfacing of peripheral chips. Now, when it comes to memory interfacing, we can interface different types of memory chips with 8086. Okay, you can interface RAM chips, you can interface EEPROM chips, ROM chips. Okay, RAM chips or ROM chips with 8086. Now, tell me, what is the address range of 8086? What is the address range of 8086? How much amount of memory does 8086 can address? What is the addressable memory of 8086? Come on, you know the answer. Speak it out. You know the answer. Just speak it out. Doesn't matter if you go wrong. How much is 2 raised to 16? If the address bus is 20-bit, how much addressable memory will 8086 have?
1 MB,
1 megabyte.
How did you get that 1 megabyte? It is
2 raised to 20.
2 raised to 20, ma'am.
2 raised to 20. Okay, not 2 power 16 is the size of the
Data bus.
data bus. Okay, so you know that 8086 has a 1 megabyte addressable memory. So, suppose this is our 1 megabyte addressable memory. What is the address range? What will be the starting address? What will be the starting address? I'm asking you.
0, 0,
0, 0, 0, 0, 0. What will be the ending address? The starting address is all ending address. Starting address is all zeros. Ending address is obviously going to be all ones. That means F, 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 F. So this is our address range of 8086 memory, right? Now what we are going to learn is how to interface memory with 8086. Okay, that is how to interface the memory with the processor. Now when it comes to interfacing, there are three things which is important. Okay, so first you need to decide the size of the memory, okay, which you want to interface. So once you decide that this is the amount of memory at which I want to interface, say, what is the amount of memory? So you may not want whole of this memory to act as a ROM or a RAM. You may want some amount of the memory to act as RAM. You may want some amount of the memory to act as ROM. I hope you know what is meant by RAM, ROM, EEPROM. What are all those things? What is RAM? What is RAM? What is the expansion of RAM? Come on, you've learned this in DLCA, right? What is RAM?
Random access memory.
Okay. What is ROM?
read-only memory.
Memory.
Read-only memory. Okay. Which is the memory which can be written to only once? Out of these two, which is the memory which can be written to only once? That means it cannot be modified once it is written to. क्वेश्चन थोड़ा घुमा के पूछा तो आप जवाब नहीं देते हो. Which is the memory which can be written to only once?
ROM.
ROM. What is the name? Read only memory. Read only memory means what? You can write to it only once. Rest of the time you can do a read operation only, right? You can have two types of, mainly two categories of memory which you want to interface, RAM or ROM. So you have to decide how much of your memory is going to be a RAM, how much of your memory is going to be the ROM, right? So that is what is meant by decide the size of the memory. Now once you decide the size of the memory, you need, so deciding the size of the memory also involves deciding the number of chips. If I want this much amount of my memory to be a RAM, how many memory chips will I require to implement that, actually implement? So you need to decide the number of chips that will be required to implement that much amount of RAM capacity or ROM capacity. So the second step in interfacing involves deciding the number of chips involved. Okay, that means how many RAM chips you will require. Say if I say I want a 128 KB RAM, if I say I want 128 KB RAM, then how many chips I'll require to have this 128 KB RAM? Or say if I say I need a 64 KB ROM, how many ROM chips will I require? So you need to estimate the number of RAM chips required and the number of ROM chips required. Okay, ROM or EEPROM, whatever it is. You know what is EEPROM, right? EEPROM. Suna hoga na? I think you've learned the classification of memory in DLCA. RAM, ROM, EEPROM, PROM, EEPROM. Suna hai na?
Yes, ma'am.
Okay, so the first step is about deciding the size of the memory. Okay, it is also called as creation of the memory map. Okay, deciding the size of the memory is also referred to as creation of the memory map. Then you need to estimate how many chips you require to implement that much memory. Okay, and the third thing that you do is called as actually creating that circuit, actually interfacing your MUPI with the memory, and that is called as memory address decoding. Okay, the third step is memory address decoding. So based on the information that you have gathered in the first two steps, you need to actually design the circuitry. Okay, so that you can do read write operations on the memory through the processor. Okay, what is memory address decoding? Memory address decoding is यहाँ पे जो आपने बनाया memory map is your plan. Okay, and your second step tells you how many chips you require to implement that memory map. The third step is actually implementing, converting that plan into a circuit is called as memory address decoding. So here you will actually generate the circuit so that you can perform, the MUPI can perform read and write operations on the memory. Okay, you know that memory has higher bank, lower bank and all, right? So only once you implement the circuitry, you will be able to select a particular bank and do read operation or write operation on that. That actual circuitry interfacing part is called as memory address decoding. So whenever you do interfacing, you need to do these three things. Okay, decide the size of the memory. That means you have to create the memory map. Second step is estimate the number of chips that is required to implement that memory map. And the third thing is designing the circuitry, which is also referred to as memory address decoding. Is that clear? Till here, what I've told, is it clear?
Yes, ma'am.
Okay, this is going to be a sure question for your university exam and for your unit test. Okay, it's a slightly complicated topic. It will stretch for 2 lectures. So here you have a whole numerical, which may be 12 to 20 marks. Okay, 12 to 20 marks numerical question based on this concept which we are learning today. Okay, we are going to discuss the numerical in a short while. So I need your full attention here. Okay, now, so I told you that the memory is 1 megabyte memory, out of which some portion may be RAM, some portion will be ROM. Okay, depending upon the requirement, user requirement. Okay, so now what you have to keep in mind is that the beginning portion of your memory is always occupied by the RAM. Okay, that means RAM always starts from the address 00000. Okay, it is not so. It is not necessary that beginning portion. The beginning portion should be RAM. Okay, you can have other RAM chips also. You can have other RAM bands also in the memory, but the beginning 4K locations of your memory is compulsorily going to be RAM only. Okay, and where will your ROM come? Your ROM always ends at address FFFFF. That means the last certain locations of your memory is going to be ROM. Okay. So the point is that while interfacing memory to 8086, you must ensure that at least 4K RAM is available at the beginning of your memory and at least 4K ROM is available at the ending of your memory. Okay. So what is the point that I've made just now? Beginning 4K, you have to ensure that when you're interfacing, the beginning 4K is going to be RAM and the ending 4K is going to be a ROM. Okay. Now, where did this 4K come from about? See the chip size, okay, of RAM, ROM, all this is 2K. The minimum chip size the minimum size of chips that come for implementing RAM, ROM, etc. is of 2K. Okay. And you know that whenever we implement memory, we have an even bank and we have an odd bank. right? So 2K into 2 is what? 2K into 2 is 4K. So the 2K restriction is because the smallest memory chip available is of 2K. Okay. The smallest memory chip available is of 2K. And we have this even bank, odd bank concept, right? So that means we require two chips of 2K each. That is how you got this 4K. So in 8086, the 2K restriction is because the smallest memory chip available, the 4K restriction is because the smallest memory chip available is of 2K. Okay. So just keep in mind that RAM will always start from address 00000 and ROM will always end at address FFFFFH. That means the last some portion of your memory is going to be ROM and the first portion of your memory is going to be occupied by RAM. Okay. So that means you know the starting address of RAM, and you know the ending address of ROM. Okay. So this much information you have right now, that the starting address of RAM is going to be 00000, and the ending address of ROM is going to be FFFFF. So this is the preliminary information which you have at hand right now. Using this information, you have to proceed. Okay. Now, if I know the ending address of ROM, can I estimate the starting address of ROM in any way? If I know the ending address and if I know the capacity of ROM, okay? So if I say I want a 128 KB, I want a 128 KB EEPROM. Okay. So I have this requirement. I need 128 KB EEPROM. Okay. I know the ending address of where my EEPROM is going to be. With this information, can I estimate the starting address? Can I estimate the starting address?
Yes, ma'am.
Forget about RAM ROM. Okay. Suppose this is a big block. Okay. This big block. Okay. You know the size of this block. You know the size of this block and you know the ending address of this block. So if you know the size, won't you be able to estimate the size of, won't you be able to estimate the starting address? You will be able, you will be able to estimate. How will you estimate? See, this is 128 KB. Ending address, you know, it is F, 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 F. And this is 128 KB. 128 KB is how much? How much is 128 KB? It is 2 power 7 into 2 power 10, right? That means it is nothing but 2 power 17. 128 KB is 2 power 17. So how do you write 2 power 17 in hexadecimal? How will you write 2 power 17 in hexadecimal? It is going to be 1 1 1 1 1 1 1 1, right? 1 1 1 1 1 1 1 1 and then 1 0 0, right? Is this 2 power 17? This is 2 power 17, right?
Yes, ma'am.
So this is what? This is F, this is F, this is F, this is F, and this is 1, right? So 2 power 17 is what? 1 F, 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 F. Now what do you know? You know the ending address. You know the ending address is F, 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 F. You know the size is 1 F, 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 F. So how will you get the starting address? How will you get the starting address? By
Address minus set size.
by subtracting. So from F, 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 you will be subtracting 1 F, F, F. So what you will get? You will get this as E000. So that means what you got? You got the starting address of your EEPROM, right? Similarly, if you know the size of RAM, won't you be able to estimate the ending address of RAM? If you know the size of RAM, won't you be able to estimate the ending address of RAM? Yes, because you know the starting address, right? So once you know the size of RAM, you will be directly able to estimate the ending address of your RAM. So that means With this information, if we know what is the size, what is our requirement of RAM and ROM, we'll be able to estimate their starting and ending addresses. Okay. So this is how we'll begin doing interfacing. Now everybody take a notebook and pen. Take a notebook and pen and take down the question which I'm dictating. Okay. Take a notebook and pen. Very important topic. If you pay attention sincerely, you'll be able to grab it. Okay. And do it right now itself. Don't keep things pending. Take a notebook and pen. Done? Leah, submit. Give me an effort.
Yes, ma'am.
Okay, now write down the question. Design an 8086 based maximum mode system having 32 KB EEPROM using 16 KB chips and 128 KB RAM using 32 KB chips. Okay, so the question is, design an 8086 maximum mode system having 32 KB EEPROM using 16 KB chips and 128 KB RAM using 32 KB chips. Okay, so for RAM, this is the capacity that you want. For ROM, this is the capacity that you want. This is the size of the chips which is available for ROM. This is the size of the chips which is available for RAM. Okay. Now what you need to estimate? First, we'll begin with EEPROM. Okay. We'll begin with EEPROM. How much is our requirement for EEPROM? How much is our requirement? Tell me.
32 kg. 16.
32 kb. Requirement is 32 kb. How much is available for ROM? EEPROM. ROM means EEPROM. Okay?
16 kg.
16 kb is available. Now you tell me how many chips will I require?
2.
2, right? Because your requirement is 32 kb, your availability is 16 kb. That means you will require 2 16 kb chips to implement this 32 kb EEPROM, right? So you estimated the number of chips. This is how you have to estimate the number of chips. Now you tell me the starting address and ending address of EEPROM.
Starting 0000.
EEPROM. I told you, give me the starting address and ending address of EEPROM. I told you how to calculate. You calculate and tell me what is the starting address and ending address. ये RAM का और ROM का चारों का सही जो बताएगा. Okay, single person. Okay, if the same person gives me the right answer for starting address and ending address of both EEPROM and RAM, I'll give you a chocolate. Okay, 10 rupees dairy milk when you come for labs. सही है, चारों आंसर सही होना चाहिए. If anybody is willing to give out the answer, you can give. I'll give you 2 minutes to find out. To find out the starting address, ending address of RAM, ROM, both, and give me the answer. Okay, I'll give you 2 minutes. Recording is on, right?
Ending address of ROM FFFFFH.
Okay, ending address you are saying it is FFFF. Very good. Then give me the starting address. Starting address. I want all four. Nobody who has got all four addresses?
F8,
Hmm.
F800,
F8000, right?
yes,
Very good. Who gave the answer?
Komal.
Komal. Very good. Komal, how did you get this F8000 for others who are wondering? Yes, Mila? FFFF is the ending address. Ending address minus
The size,
size. What is the size?
32 KB, that is 2 raised to 15, then 0,
2 raised to 15. So what is 2 raised to 15? 1, 1, 1, 1.
7, FF,
1, 1,
F,
1. So this is what? This is 2 raised to 15, right? So this is going to be 15 nahi hua? 4, 4, 8, 12 plus 4. Okay. Hua na?
yes, ma'am.
So this is what? This is
07, FFF,
FF, right? So this is going to be 07FFF. So what do you get?
F8,
Hmm.
0, 0, 0.
0. Very good, right? So this is how you estimate the ending address. Now, Komal, tell me the starting and ending address of RAM also. For RAM, required is
128,
128 KB. Available is
32.
32. So number of chips is 128 by 32. How much is it? 4 chips, right?
4 chips.
Very good. Now tell me, starting address you already know for RAM. What is the starting address?
So,
Starting address is 0000, right? Now you tell me what is the ending address? What is the ending address?
starting address plus set size.
What is it? It is 128. 128 is how much? 2 power
17.
17. So you have just,
And
it will be what? 1 F, right? Yes. Now,
So that is the first step.
okay, you have to do. First, you have to estimate the number of chips and starting and ending addresses. Now the next thing that you have to do is you have to find out the number of address lines required for EEPROM and RAM. Okay. We'll begin with EEPROM. What is the number of address lines that is required for a single EEPROM chip? Requirement is 32 KB, but we are not going to implement that requirement using 32 KB because we don't have 32 KB chip available, right? We have only 16 KB chips available. That means that is our availability. So how many address lines will require? How much is 16 KB? 16 KB is how much? 2 power 4 into 2 power 10, right? That means how many address lines will require? Will require 14 address lines for doing this interfacing. Okay. Similarly, for RAM, how many address lines will require? What is our availability of RAM? It is 32 KB. 32 KB is what? 2 power 5 into 2 power 10. That means we will require 15 address lines for interfacing this particular RAM chip. Okay. So after estimating the number of chips and starting ending addresses, the next thing that you have to estimate is the number of address lines required. Okay. How do you get the address lines? Whatever is availability, 16 KB. So it is 2 power 4 into 10. That means we require 14 address lines. So 14 address lines means, which are the 14 address lines? It is going to be A1 to A15. Okay. Not A0 to A14. Why not A0 to A14? क्योंकि A0 का काम कुछ और है, मैंने बताया है. A0 का काम क्या है? What is the job of A0? What is the job of A0? बोलो क्या forgot about memory banking?
बैंक्स जो है तो मैम आइडेंटिफाई करता है.
हाँ, A0 is used for selecting the memory bank. It is not used for address selection, right? So that is why I've written it as A1 to 15. Sorry, A1 to A14. Sorry, A1 to A14. Now, here, what will it be? Here the address lines will be A1 to A15.
A15.
Okay. So what all things you have to estimate? Number of chips estimate karna hai, starting ending addresses estimate karna hai. You have to estimate the number of address lines required also. Then only you can proceed to the next step, which is the creation of memory map. Okay. So we are proceeding to the next step, which is about creation of memory map. Till here, is it clear to everybody what all things we have estimated?
Yes ma'am.
Yes, ma'am.
Okay, now let's go to the memory map. Okay, this is the memory map of our requirement. हमारा system का memory map. हमारा system क्या है? It's designed an 8086 based maximum mode system having 32 KB EEPROM using 16 KB chips and 128 KB RAM using 32 KB chips. That is our requirement. Okay, so this is the plan for that. Now, what is a memory map? Memory map is nothing but a pictorial representation. Okay, it's a graphical representation of the total available memory in a system. Okay, and how it is. That means how are the bands distributed? That means starting address क्या है, ending address क्या है, RAM, ROM का starting ending addresses क्या है, वो सब आपको एक graphical representation में दिखता है. That is called as the memory map. So it's basically a picture of your memory. Now, we have estimated how much is our RAM and how much is our ROM. Okay. So RAM के लिए हमें कितना चिप्स लगता है? How many chips do we require for RAM?
4.
4. ROM के लिए 2 chips, right?
2.
So you see here, RAM 1, RAM 2, RAM 3, RAM 4. 4 chips for RAM. Okay. For EEPROM, we want only 2 chips. So this is EEPROM 1 and this is EEPROM 2. Okay. So first column is memory chip. RAM 1, how many RAM? Always your memory map will always begin with RAM only. Okay. So you will write RAM only first. So RAM 1, RAM 2, RAM 3, RAM 4. RAM 1 जो है वो आपका lower bank होगा. RAM 2 आपका higher bank. RAM 3 will be again your lower bank and RAM 4 will again be a higher bank. Right? It's a lower bank, higher bank combination. Right? So this is called as your band 1. Okay. This is called as your RAM band 2. This is your RAM band 1. This is your RAM band 2. And this is your ROM band. Okay. ROM band 1. So together, the lower bank and the higher bank together are called as a band, single band. Okay, BAND. Now, so first column सबको समझ में आया why it is 1, 2, 3, 4 and why it is EEPROM 1, 2, right? समझ में आया ना first column? Respond.
Yes, ma'am.
Now look at this column, memory address. Memory address also we have estimated. RAM का starting address क्या है by default? By default, RAM will start from 00000H, right? और RAM का ending address हमने estimate किया 2 power 17, है ना? 2 power 17 is the ending address of our RAM. 2 power 17 is nothing but 1FFFFH. Correct है ना? अपना starting और ending RAM का correct है? Correct है कि नहीं?
Yes, ma'am.
अभी similarly, we have estimated the starting address of EEPROM. EEPROM का starting address क्या है? We have estimated it as F8000 and ending address is by default FFFFFH. So that also is correct. The starting address and this ending address is also correct. Now we need to find out this one, how to split it into 2 banks, right? So banks में कैसे जाता है चीजें? आपको याद रहेगा बैंक में चीजें कैसे जाता है? अगर 0000 इवन बैंक में है तो 0001 वाला एड्रेस कहाँ पे जाएगा? कहाँ पे जाएगा?
odd.
ऑड बैंक।
ऑड बैंक।
तो ये देखो, ये अपना इवन बैंक में गया 0000, तो मतलब 0001 कहाँ पे जाएगा? ऑड
ऑड
बैंक।
बैंक।
That means your even bank will start at address 00000H and your odd bank will start at address 00001H. Right? Right?
Yes.
Now
Yes,
you,
ma'am.
now you tell me, how did I get this ending address? How did I get this ending address? Bolo?
Plus 64 KB.
Not 64 KB. Just think and tell me, how did I get these ending addresses? Take 2 minutes, think, you will be able to see. If this is going to be 0 FFFFE, this is obviously going to be 0 FFFFF. क्योंकि 0 अगर इवन बैंक में जा रहा है, 1 ऑड बैंक में जाएगा। ऐसे ही आप लास्ट का जब कंपेयर करोगे, अगर ये 0 FFFF है तो ये 0 FFFFE होगा। बट हाउ डिड आई गेट द 0 FFFFE? दैट इज व्हाट आई एम आस्किंग। think chocolate, chocolate, I'll give the chocolate, huh? If you give the right answer.
हम 1 RAM का 32 KB है तो 2 का 64, तो 2:16 होता है वो, that is 4 times F.
Pardon, repeat it once again.
मैम एक RAM का 32 KB दिया है तो 2 का 64, which is nothing but 2:16, that's why 0 and 4 है.
1 ग्राम का 32 KB, just a minute. हाँ, 128 KB RAM using 32 KB chips. So
तो दो चिप का 64 मैम, that is nothing but 2:16,
हाँ,
which is
very
0.
very good. Who is giving me the answer? Who gave
Akshay.
the answer? Akshay, very good. एक चिप का साइज कितना है? Look at the question. The question itself has all the information. That is our question. It is 32 KB chips, 128 KB RAM using 32 KB chips. 32 KB means what? 32 KB means what?
2:15.
Then? So it is 232 KB chips. That means 64 KB chips. That means the ending address is going to be what? 0FFFFH, right? This is what? This is one chip. This is a second chip. So it is 64 KB chip. So 64 KB chip मतलब उसका ending address क्या होगा? 0FFFFH, right? है ना? और अगर ये 0FFFFH है तो ये obviously 0FFFEH होगा, right? Because even odd, when you look at the comparison of even odd address, if this is 0FFFH, इसके जो पहले का एड्रेस है वो even बैंक में जाएगा, right? So this is 0FFFEH. Similarly, अगर ये 0FFFFH है तो उसका immediately next address 0FFFH plus 1 will go into where will be the starting address of your RAM 3. This 0FFFH plus 1, the next address 0FFFH plus 1 will go where will be the starting address of your next
RAM 3.
तो अगर ये 1000 में शुरू हो रहा है तो उसका एंडिंग एड्रेस क्या होगा? 1FFFH, राइट? हाउ डू यू कैलकुलेट द स्टार्टिंग एड्रेस? स्टार्टिंग एड्रेस में जो भी जीरोस है वो आपके रिजल्ट में 1 बन जाएगा. सो दिस इज 1. So what will be the ending address? Ending address will be 1 f of h. So you can see 1 f of h. So if this is 1 f of h, this will be what? This will be 1 f of h, right? Anna?
Yes.
Huh. See, address 0 goes to even bank. Address 1 goes to odd bank. वैसे 2 इधर, 3 इधर, 4 इधर, 5 इधर, ऐसे जाता है. So अगर 0 0 0 0 even bank में जा रहा है, 0 f of h will go into the other bank. Will be the 0 0 0 1 will go into the odd bank. Similarly, for it applies for the ending addresses only. Also, so this is not just two address. Okay, there are lot of addresses between this. So this is actually a range. यहाँ पे हमने सिर्फ starting और address and ending address mention किया. So this is not just two addresses. There are lot of addresses between this range. Okay, so what we are showing is a plan, a map of our memory. But we are mentioning just the starting and ending addresses of our banks and banks. Similarly, agar F8000H is the starting address of EPROM, ending address is by default we know FFFFH. तो अगर F8000 यहाँ पे even bank में जा रहा है तो F800001 will go into odd bank, right? That will be the starting address in your odd bank. और अगर FFFH is the ending address in your higher bank, what will be the ending address in your lower bank? It will be FFFFEH, right? Right or wrong?
Yeah.
Huh. So now what is written here? This is nothing but the expansion of this address, right? This is nothing but the expansion of this address. So you can see here, this is 00000H. So you can see here 000000000. So this is 00000H. This is what? This is 0 triple F E H. So you can see here, this is 0 triple F E, right? This is what? 00001. So this is 00001. This is what? 4 Fs. So you can see this is 0 F F F F. So what you have written here is nothing but the expansion of this memory address. So this is what? 00001. 1 followed by 4 zeros, right? This is what? 1 triple F E. You can see this is 1 F F F E. This is 1 0 0 0 1. This is 1 F F F F. Right? This is F 8 0 0 0. This is F F F F E. This is F 8 0 0 1. This is all Fs. So what you have given here is nothing but the expansion. Okay. 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 So how did we estimate this memory map? We have already calculated the number of chips and the starting and ending addresses. From that data, from that information, we have to just create this memory map. So first, you will write down the number of chips that are required and their type, whether it is RAM chip or EPROM chip. Always remember, memory map begins with the RAM chip only. So here, according to our question, we need 4 RAM chips. So we have RAM 1, RAM 2, RAM 3, RAM 4. EPROM 1, EPROM 2. And then we have to write down their address ranges. We know we have already estimated the starting address of our RAM, which is 0. By default, it is going to be 0000Hs, and ending address we have already estimated, which is going to be 1 F of H, right? Then from this data, we have to estimate the starting and ending addresses of the lower bank and higher bank. So if 00000H is going to be the starting address of the lower bank, then the starting address of the higher bank is going to be 00001H, right? Similarly, we have to estimate the ending addresses also. So this we have to do for both EPROM and the RAM and the EPROM chips. So what you get as output is your memory map. So is the memory map clear to everybody?
Yes, ma'am.
अगर आप
Yes.
if you observe the memory bank, okay, your memory bank is going from A0 to A19. That means it is a 20-bit address, right? It's a 20-bit address. It's a 20-bit address. 8086 का जो address है वो 20-bit address है. उसमें अगर आप A0 को observe करोगे तो देखो A0 RAM1 is your lower bank. For lower bank, this is going to be 00 only. For higher bank, this is going to be 11 only. See, for lower bank, this is 00. For higher bank, this is 1. मतलब lower bank के लिए A0 हमेशा 0 रहता है, higher bank के लिए A0 हमेशा 1 रहता है. Similarly, for RAM 3 and 4, you can observe. Lower bank के लिए A0 जो है वो 0 रहता है, higher bank के लिए 1 रहता है. EEPROM के लिए भी वैसे ही है. EEPROM के लिए lower bank में 0, higher bank में 1. So A0 is not involved in selecting an location. A0 is involved in selecting a particular bank only. Keep that point in your mind. Okay. So till here, I hope it is clear to everybody. Okay. Now next, we have to learn this interfacing part. So this is the circuitry which is going to implement our memory map. ये हमारा plan है. Okay. Now we have to convert this plan into the circuit. So that we will be discussing in the next session. But if anybody has not understood how we have created the memory map, please revisit the lecture recording once more. Only once you create the memory map, you will be able to construct the diagram. Okay, the diagram might look scary, but it is very easy. Okay, so if you get a theory question and this interfacing question, I would always suggest you to attend the interfacing question only. It's very easy to draw this diagram provided you get the logic. Okay, it's not as scary as it appears. So in the next session, I'll tell you how to create the circuitry. Now, everybody please take down 2 homework questions. Take down 2 homework questions. You will create the memory map for these 2 questions and you will come. Okay. Write down the questions. Only the memory map you have to create. Okay. That means you have to estimate the number of chips and the starting and ending addresses. Take down the question and after that you can leave. Write down. Design an 8086 based minimum mode system working at 6 megahertz having the following requirements. Okay, 128 KB EEPROM, 128 KB EEPROM using 32 KB chips. Have you written it down? 128 KB EEPROM using 32 KB chips. 128 KB RAM using 64 KB chips. 128 KB RAM using 64 KB chips. Have you noted it down?
Ma'am, please repeat from start.
Okay, I'll just write it down here. 128 KB EEPROM using 32 KB chips and 128 KB RAM using 64 KB chips. This is the first question, okay? The second question is 64 KB EEPROM using 16 KB chips and 256 KB RAM using 64 KB chips. So you have to create the memory map for both these questions. Okay, first estimate the number of chips and starting and ending addresses and then create the memory map. I'll ask one of you to share your screen. Okay, so everybody will keep that sheet ready. Keep a scanned copy of this sheet ready. Okay, the memory map of these 2 homework questions which I've given. I'll ask one of you to share the screen tomorrow. Tomorrow nobody will give me any excuse. Okay. Whoever I'm asking will share your screen and show me the memory map of both these 2. Okay. One person will show the first question and the other person will show the second question. But you should have the memory maps of both these examples ready. Okay. See, once you understand this memory map only, you will be able to design the circuitry. That's very easy to design, but you need to get the crux. Okay, we'll wind up now. Those who have marked your attendance can leave. Those who have not marked your attendance, please mark your attendance in the chat window.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yes.